Okay, so loving, if you're listening, what we're gonna do today, because we haven't done a lot of work, first thing we're gonna look at ions in aqueous solution by just doing dissociation and ionization reactions. This hydration here is just gonna be theory. You're gonna get it, and then Gabby is gonna send me a photo of this 3.1.3 because I'm not 100% sure what that is, and then the applications here is just gonna be theory. So we're going to be looking at dissociation, ionization today. And then next week, we'll be looking at this very important section here on precipitation reactions. Okay, this is just what is a precipitate. You're just going to learn it, look at it, right? And then we're going to be writing these equations. And this is going to be, I don't know why they put ion exchange reactions there because these are exactly the same. I'm going to put ion exchange reactions with our precipitation reactions. And then we're going to learn when precipitation happens. There's a table, and this is the really important part that you tested on the exam that can count a lot of marks, and that's the test for various ions. So next week, we're going to look at that. And then lastly, we're going to look at redox reactions. So that's a big section, but sometimes your textbook only like does a little section for the grade 10 work. Okay, so that's like in summary what we're going to do. Okay, so this is the table that I was referring to. We're not going to use it today, so I'm just cutting it out here and I'm pasting it there. Right, okay. Are you with me, Gabby? Yes.
Yes, I am so.
Okay, dissociation and ionization. Now, very important, the word dissociation, that's where we actually get the word dissolve. Now, this is a physical reaction. It's not a chemical. So this is not a chemical reaction. I'll explain how this works. While ionization is a chemical reaction. Think about it. If you take a glass of water and you put salt in it and you stir it, there's no chemical reaction taking place. All that is happening is actually that the salt is dissolving in the water. Do you understand that? So that's just this. It's not a chemical reaction. It's just a normal dissociation reaction. And all salts, now very important, a salt consists of a metal that's bonded to a non-metal. Now, maybe you can help me here. What type of bonding is that? What is a bond between a metal and a non-metal? Do you
Um,
remember? Is it
uh,
covalent or ionic or metal bonding?
Metal bonding.
No, ionic bonding. It's an ionic bond. Why? Because the metal, let's use sodium, has a positive charge when it becomes an ion, and all non-metals, we're going to take chlorine because that's salt, sodium chloride, and chlorine is going to become a negative ion when it ionizes, and then that positive ion and negative ion is going to bond to one another, and that's called the ionic bond because ions are bonding. So what happens here? I don't know if you've got in your textbook a little like I can actually find an animation for that. I'll show you in a second. Just help me remember that I get an animation. So if we have sodium chloride, which is a solid, table salt, it actually consists of this positive sodium ion and the negative chlorine ion. And because it's not a chemical reaction, but a physical reaction, if we dissolve it in water, we write water or H2O, we write that on the arrow. We don't write sodium chloride plus water. Normally, we write chemical reactions like that. But a physical reaction, we're just going to write the water on top of the arrow. And what then happens is the sodium ions comes loose in an aqueous solution. So AQ means aqueous solution. So there's sodium ions in aqueous solution. And then chlorine ions also in aqueous solution. That's called dissociation. It dissolves. So that structure, that sodium chloride structure, dissolves in water. So what happens is, I'm going to I'm going to make the sodium ions pink, and the chlorine ions I'm going to make purple. So let's just, I'll show you I'll show you an animation just in a second. So let's just duplicate that. Boom. So look at this. Look at this structure. So there's all the chlorines and in purple and all the sodiums in pink. Can you see that, Gabby? Oh, wow. The purple and the pink doesn't really look different, does it?
No, not at all.
Let's redo that. Okay. Let's make these green.
That's much better.
That's much good. I didn't even actually notice that. So let's duplicate. Let's redo that. Otherwise, it's going to struggle. Boom, something like that. Duplicate. I'll show you an animation in a second. Let's put it there. Okay. So the chlorine is green and the sodium is pink, for instance. So what happens, these are a water molecule. Okay, I'm going to show you what the water molecule looks like. There's the oxygen. And there's the two hydrogens. Duplicate. Now, if you can remember, we drew Lewis structures of these. There's the water molecule. Can you remember that? So the two hydrogens are blue and the oxygen is red. Can you see that?
Yes, sir.
Okay, if you maybe you can remember what the water molecule looks like, or the Lewis diagram. There's an oxygen there, and then it bonded to a hydrogen there, and the oxygen and hydrogen bonded there, and the oxygen had two lone pairs of electrons. Do you remember that?
Yes.
Okay, so this side is negative and this side is positive. So we have a positive side here of the molecule and a negative side there. So that positive side can actually come and grab this chlorine here. That chlorine there is, that green chlorine there is negative. So once the water molecule comes closer to the chlorine, it just grabs the chlorine and pulls it away. Okay. So that's what this is. This is the chlorine ion in an aqueous solution grabbed by water. Okay. Now look at this. I can also take the water molecule and flip it around. So its negative side comes closer towards this crystal lattice here. So if the negative side comes closer, remember this oxygen side is negative and this sodium ion is positive. So what will happen then, do you reckon?
It will take the chlorine.
It will take the sodium, no?
Oh,
There, it's grabbing the sodium with the negative side and it pulls it away. And this is what this section is here. The sodium ion is in an aqueous solution. It's surrounded by water molecules. So what I'm going to do, I'm quickly going to go and find. So dissociation of sodium chloride. I'm looking for a little video or something. Okay, I'm going to share another screen with you. Hopefully this one is actually fine. It works well. Can you see a new screen, Gabby?
yes, I can, sir.
When an organic substance such as sodium chloride is placed in water, water molecules.
You see what water molecules do? Can you see it?
Yes, I do.
Interactions with water molecules.
So the water molecules comes. I just want to shut up this woman. So what happens is the water molecules comes and the negative side goes to the positive sodium ion and the positive. So there we go. The green one is the chlorine surrounded by water molecules. And the positive white one is the well, okay, they've got oxygen. Yeah, I don't know why they've got. Okay, the oxygen positive side gets the sodium away. So it just pulls it away. That's not a chemical reaction. That's a physical reaction. And it's called dissociation. Okay.
Okay.
Let me just get this page back. So you're going to be asked to give a definition of dissociation, and you're also going to be asked to actually, what's happening with my screen? There we go. Is it back?
Yes.
Okay, so dissociation is always when a salt is just a combination of a metal bonded to a non-metal, dissolves in water. And that's not a chemical reaction, that's like a physical reaction. Okay. Happy?
Yes.
All your
I'm just
bases
writing.
a base will also undergo dissociation. So now we have sodium chloride. So this is, you must be able to recognize this as our ionic bonded substance. Similar to the following one. If I have magnesium bromide and we're going to add water, then you must realize that's a metal. And this is a non-metal. Do you know how to know if it's a metal or a non-metal?
The periodic table.
On the periodic table.
But before we go on, so do you mind just quickly going back to that little drawing of the,
This one.
so yes. Okay, perfect. Thank you, sir. I've got it now.
Okay, it's going to be on video as well. So, okay, now
Uh,
once you realize that it's a metal bonded to a non-metal, it's actually a salt or a ionic bonded substance. So then if you do, then dissociation is going to take place, not ionization. So we're going to write water, and that small L there in brackets is to say that it's liquid. It's not in solid state or in gas, because water can also be in a gaseous state, like it's called vapor. Or water can also be in a solid state, ice. Now, it doesn't help you take magnesium bromide and put it in ice. You have to put it in water, which is in liquid form. Then what's going to happen, the magnesium ions, remember magnesium is in group 2, so that's going to be 2+ ions, are going to be in an aqueous solution. And also the bromine ions, which is Br1 minus because it's a group 7, that's also going to be in an aqueous solution. And I'm just going to put a 2 in front of the bromine ion to balance the equation. Do you understand that?
yes, I do.
And this is called dissociation. Dissolves. Okay, so these are also is very important. And then also what you must remember is that almost all your bases except ammonia, which we'll look at in a minute, all your bases, a base is a group 1 or 2 element, like lithium, and connected to hydroxide. So that's a strong base. And that will also undergo dissociation. Why? It's again lithium, which is a metal, bonded to a, well, it's a it's a non-metal hydroxide, but the whole of hydroxide is non-metal. So again, that will undergo dissociation where lithium ions are in an aqueous solution and also the hydroxide ions are in an aqueous solution. So this is dissociation is all your bases. All bases dissociate, except one. We'll look at that in a minute. Dissociate. Okay, good. Got it?
Yes.
Okay, and then important, your textbook also does it correctly. It actually takes the water and put it onto the arrow. Okay, now we go back to ionization. Ionization is a chemical reaction. Okay. And ionization takes place. I'm just going to take this and make it smaller because we are out of this section. Ionization takes place when a covalent bond bonded substance, in other words, no metal, there's no metal, reacts with water.
That's ionization.
Ionization, yes. Ionization is a term that we use when a covalent bonded substance reacts with water. So now this is a physical reaction, and all your acids will undergo ionization. Why? All your acids consist of bonded ion atoms, which are bonded covalently. Like hydrogen chloride, if you draw a Lewis structure of that, you'll find that electrons are shared between the chlorine and the hydrogen, and that makes it a covalently bonded substance. Okay, so that can be a liquid. That can already be in an aqueous solution. It can actually be in a gas form. It doesn't really matter, or a solid. And that you will allow to react with water. So we're not writing water on the arrow. We're writing it as a reaction. And that will, I'm going to teach you something that's actually, we're going to do sometime later only. But it's kind of useful now, because if you want to write this reaction, you don't know what to do. Now, your covalent substance, that one, if it's got a hydrogen, yeah, okay, it's very difficult for a grade 10 student now. If it's an acid, how do you know if something's an acid? We're going to learn.
It's very corrosive.
Yeah, but how would you know that HCl is an acid if you can't put it on your hand and feel if it's corrosive? Okay, I'm gonna teach you a couple of acids, but most of the time, if it's an acid, always, but most of the time, this substance will give a proton, which is a hydrogen ion, away. Okay. Now, this is going to be a slightly difficult for you because you haven't done it. I'm just going to make 100% sure. Yeah, they are just expecting you to learn this. Okay. But I'm going to show you how it works. Okay, if it's an acid, I'm going to teach you what the acids look like. The acid, all that the acid's going to do, the acid's going to take the hydrogen and give it to the water. So what's going to happen to the water? The water is going to get another hydrogen. Can you see now H2O becomes H3O?
Yes.
And because a hydrogen is charged positively, I add a charge there, so it becomes positive H3O. That's called hydronium. And that's also now in an aqueous solution. And that what remains from the acid is just Cl remains, and it is Cl minus because that's a chlorine ion. If you remove the water, then if I remove that hydrogen there, take it away, then the chlorine's got one extra electron attached to it. So it's got a negative charge, and that's chlorine ions in aqueous solution.
Okay.
I'll quickly write that, and I'll show you the acids. All the acids that you need to know. It's not a lot of them.
Is this process called hydronites?
No, this is
Sorry,
called ionization.
What is this process called? Hydration.
No, ionization.
Okay.
Hydration is just hydration is just a big term when water molecules surround any other ion or atom. If you hydrate something, you add water. So this does qualify as hydration, but it's called ionization.
And what was it called when the H is given to the oxygen?
Oh, that's just
to
called
the H2O?
proton donation. But that's slightly out of the grade 10 syllabus. I'm just teaching you how to write the equations.
Okay.
You'll see now. Can I continue?
Yes, you can, sir.
Okay, so let's. Okay, what's happening here? Okay, we've done this one. This is not applicable for now, so let me delete this. Let's delete this. Okay, so now let's look at our acids. Just want to add a page for acids. Oops. Page. Acids. Okay, so we've got hydrochloric acid, HCl. Okay, then we've got sulfuric acid, H2SO4. Then we have HNO3, which is called nitric acid. And then we have CH3COOH. That's called, you can call it ethanoic acid, or it's called actually the acid that's in vinegar. Okay, and then what's the other one that you kind of sometimes use hydrogen bromide. That's also a strong acid. I'm just thinking, and you might use, I don't want to show you this one really, but it's in your book. So it's called phosphoric acid. Now, these two that I'm going to mark red is difficult to write equations with. It's out of the grade 10 syllabus, actually. But the rest you should be able to do. This one is really important, and this one is really important. Okay, let's also add nitric acid. Those are your important acids. I'm going to do a lot of this in grade 11. Okay, so now, in any one of those, let's start with, we've done hydrogen chloride. So let's use HNO3, nitric acid. Now, I'm not going to do subscripts. I'm just going to add water. Why am I adding water and not writing it on an arrow? Because there's no metal in that substance. So there's not going to be dissociation. It's going to be ionization. Okay, which one is the acid?
Hydrogen.
Nitrate.
Yes.
HNO3. Okay, what's the acid doing?
The acid is being diluted. So we
But
give
the acid does something. It's a donor. What is a donor? It gives. It gives something. What does the acid do? It gives its hydrogen away. Okay? So what becomes of the water? Gabs?
Sorry, sir, it's a bit noisy now, so I don't think you'll be able to hear me.
Okay. Okay, no problem. I'll be doing the speaking then. The acid gives a hydrogen away. So the water becomes H3O and +1 because it receives a hydrogen ion. It's called a proton. It's a short word for a hydrogen ion. And that is in an aqueous solution. And then the NO3 remains, but it lost a positive charge, so it becomes negative in an aqueous solution. So that's called ionization. We're going to do also the acetic acid. It's called ethanoic acid. So that reacts with water in a process called ionization. It gives this proton away, that one. And then CH3COO remains in aqueous solution, and the water gets one hydrogen, and that's called hydronium. Okay, so this is all my acids. The rest all work the same. The two red ones we're not going to do. Obviously, the hydrogen bromide just gives the hydrogen away and bromine ions remain. Then, this is an important one. So, ammonia is a base, but because there's no metals there, it also reacts with water, and it's called ionization. It's the only base that does that. Now, very important. This you must learn is a base. Okay. A base does not give hydrogen ions away. A base will receive hydrogen ions. So that base then become NH4 plus in aqueous solution. And what remains of the water is just one O and one H hydroxide ions in aqueous solution. And this one is kind of important because it's a opposite. The water gives the hydrogen away. It doesn't receive the hydrogen. Okay, make your notes here.
Okay. So I have a question with the difficult one.
Yeah.
Nitrogen hydroxide.
Where's nitrogen hydroxide?
The NH3.
No, it's called ammonia.
Oh, okay, wait, let me make a note of that. Ammonia. Okay. So
This is ammonia. That one is ammonia. And then we also have ammonium. Ammonium
Okay.
is NH4 plus. That is ammonium. Ammonium. It can get confusing with the names. That's ammonia and ammonium. Ammonia. Do you know what Handy Andy is?
yes.
The white stuff that you clean the bathroom with. I think that's like 80% ammonia. That is what ammonia smells like. It's basically ammonia.
So bleach, ammonia is another word for bleach.
No. I'm not 100% sure. But yes, you can say, but a bleach and Handy Andy is something. Bleach is called Jik.
Okay.
Well, ammonia is basically that substance that comes in that the main ingredient of Handy Andy is yeah, I think so. Yeah. It's called ammoniated cream.
Okay. That
Anyway,
makes sense.
doesn't matter. You don't have to know that. It's just this is the one that's the base, the only base that goes undergoes ionization.
Okay.
Okay, so you've done in your chemical equations for the solution process, you have the acids here. Okay, you have actually an interesting one. Molecules of sugar. And no ions. Yeah, this is the important one. Let's just look. This is one in your textbook. It's called sugar plus water. And sugar looks is C12, H22, O10, and it's a solid. And then what they do is they add water here. They just add water here. And now there's a small problem here. They just do this. C12, H22, O10, AQ. This is the way they write it. Now, there's a small problem here because this sugar molecule here, can you see the sugar molecule doesn't have any metals? No metals. And so we were like, according to my rules that I've given you, this should be a chemical reaction. But it isn't, because this is a molecule that are, it's very difficult. But sugar doesn't react with water. It just dissolves in water. This is a large structure molecule. It's not difficult to remember because you know from experience that sugar doesn't react with water. It just dissolves. So if you take that sugar that's dissolved in water and you put it on a stove in a metal cup and you boil off all the water, then the sugar is going to remain at the behind. Do you agree?
Yes.
Okay, so then if a chemical reaction happened, that would not occur, then everything will just vapor out. So they didn't bond.
Wouldn't the sugar crystallize if it had a chemical reaction?
No, it wouldn't crystallize. The sugar crystal will form at the end without a chemical reaction. If there were a chemical reaction, a new substance would have formed that wasn't sugar dissolved in water, and that you would not be able to vapor off. Like if I go back to this acid, the hydrogen chloride, that reacts with water, and that gives us hydronium ions in aqueous solution and chlorine ions in aqueous solution. Now, if you take this substance and you put it in a beaker and you heat it up, everything will dissolve. Everything will vapor off. Nothing will be left. Because these are new substances that formed that was not like anything we had. In this sugar molecule, we had C12H22O10, and what remained was C12H22O10. So nothing, no reaction took place. They're exactly the same. Okay. Good. Just want to check in your book. Maybe you want to just go quickly to the section on, what was it? Just send me a picture. I'm just curious. 3.1.3. Just send me a picture of that. Because I think we've done ionization and dissociation.
Yes. So I did an activity in the book, and it's basically the chemical equation for the dissociation. I'm gonna send it to you to see if it is correct. Is that okay?
Yeah, and then I just want to see the front page or the page with 331. Send me those two photos.
331.
Yeah, but first send me the stuff that you've done.
Okay.
Tell me when you've done it.
I've sent everything to the group.
Did you send those two pages? I'm just waiting for them to come through.
Okay, yeah.
Why am I struggling to find? Oh, it's on the group.
Yes, sir.
Okay. All right. I just want to fix this page. Gabby's photos aren't the best.
No, unfortunately not.
Okay. Okay, this is the table I was talking about. This one.
Yes.
These give you the solubility rules. We're not looking at that today. And those are equations for, it's what your book calls ion transfer reactions. So that we're not doing today. We're going to do that probably next week. And this is the test for ions. So the chapters basically overlook. So next week, we're going to be looking at precipitation reactions. And in the precipitation reactions, I'm going to do ion transfer reactions because all the precipitation reactions are ion transfer reactions. So you don't have to worry, do that in one. Okay. And then we're going to do a lesson on to test for ions.
Okay.
Okay, so this is like one section. We're going to all do together.
Okay.
Obviously, you can do that beforehand on your own and have questions. And then precipitation, yeah, it's fine. Okay. Mhm. Yes. So look at this. Just wanna take this. This is kind of also something that you have to look at. Just wanna So they're gonna give you those compounds, sodium bicarbonate.
Mm.
That's Na2CO3. Okay. And then they're gonna ask you, does it conduct electricity? Yes. Why? There are ions present in solution. So you need to find out if there are ions present in solution. Okay, so now I have a metal here and a non-metal there. So basically, this is going to be what? Ionization or dissociation?
Ionization.
No,
Oh, what's the
dissociation, because it's a
difference?
salt. A salt consists of a metal and non-metal, so it will dissolve. So now
Okay,
there will be
so
sodium ions in solution plus CO3 2 minus or carbonate ions in solution. And I'm balancing it by putting a 2 there. So the question is, will there be ions in the solution? Yes. There's the one set of ions and there's the other set of ions, and therefore it will conduct current. And now the next one is sugar. Sugar has got that molecular structure. It does not, according to me, conduct electricity because there's no ions.
mm,
Where's that sugar? That's a difficult one, actually. Where's that sugar one? Yeah,
sugar
it's
does
got no
not.
ion. It's just AQ. We wrote that equation. So it's no. Sorry, I've got a sugar already. No ions. And then table salt is what? Sodium chloride, metal, non-metal. It will dissolve, or dissociation will take place where we have sodium ions and chlorine ions in aqueous solution. Blah, blah, blah. So it does, and it has ions. And then hydrochloric acid, we've done an equation. And then alcohol. What's alcohol? Okay, you wouldn't know that. Alcohol is something like methanol. That doesn't make ions. Okay, but you wouldn't know that actually. So no ions. This is actually unfair. How would you know this?
Is that metric work?
Yeah, in a sense. So we're adding water here.
Mm.
And then what's gonna happen? I'm trying to think. Oh, it's gonna form are we adding that's no, that's not gonna work. That's just that's not even a chemical reaction. That's just gonna be stay like this. So what do you do when you take whiskey and you add water? Nothing.
You
just
dilute
like
it.
diluting it. So it's there's no ions that form. No ions. No chemical reaction either, except once you've drank it and the alcohol is absorbed in your blood, then there's a chemical reaction in your brain. Okay. Because the alcohol reacts in your brain and it dehydrates your brain. Did you know that?
No, I didn't.
So you're not dumb if you drink, you just become dumber.
Because your brain is dehydrated.
Your brain is dehydrating. If your brain dehydrates too much, you get a massive headache. And that's called hangover. So basically, you've starved your brain of fluids because alcohol does dehydrate. It takes water out of substances. So it takes water out of your brain, it dehydrates your brain, it damages your brain, and you get a headache.
So that's why a lot of hospitals use the 100% alcohol wipes because of how quickly it absorbs. dehydrates the surface of any
It
moisture.
does dehydrate, but alcohol also kills germs.
Okay.
Okay. Look, we've done enough for today. Next week we're gonna do those ion transfer reactions, and we're gonna do precipitation with that.
Okay.
Good. Have a nice day, Gabs.
You too, sir. Before
Alright.
you go, sir,
Yeah.
do you mind just checking? I sent the activity on the group. Would you mind just checking that for me quickly and seeing if it's correct?
Which one was
So
that?
I've done it. It's
Oh, okay, see it.
yes. Yes.
Yeah. I'm trying to write on this. This one is right, correct? Yeah. Very good. Yeah. Yeah. Conclusion.
Okay.
All the substances given are, but what is that? Dilutable.
Yes.
Why is that though?
Um,
It's not
yeah,
dilutable. Dilutable is not the right word.
then what is the right word?
Dilutable means you take a liquid and you add another liquid to it. You took all solids and you added water to it.
So,
Uh, all this, all the substances. I would say my conclusion. It doesn't say all the I wouldn't say all the substances are soluble. That is correct. Soluble. So that would be right. Soluble. That would be correct. But I would say my conclusion is all these ionic substances uh, dissociates in water. Ach, not this, yeah, dissociates in water. No. That is what you are actually looking at, dissociation or ionization. So I would say all of these substances dissociate in water and form ions.
all of okay. Wait, let me write
Dilutable
that.
is not correct because we don't dilute a solid. We dilute a liquid.
Okay. So all of the substances given are
All the
soluble.
substances are you can say soluble and form ions through dissociation. Okay. What is caustic potash?
I didn't know what
Is that
KOH was.
this is potassium hydroxide?
I'm assuming so. I asked Google for help because not even
Yeah,
the
but caustic soda is probably just the like table name for it, but that's called potassium hydroxide.
okay. Yes, it did say give the common name for.
Oh, common name. Okay, yeah, that's
Yes.
different.
Okay, sorry. Just the conclusion is all of the substances given are soluble and form ions through dilution.
Dissociation.
This is dissociation, sorry. It's the that's throwing me off the whole time.
No problem.
Okay. Thank you, sir.
Okay, keep well. Bye bye.
Bye-bye, sir.